I want to thank Ryan Burns and everyone who organized this panel. I really apologize for not being here. Unfortunately, my teaching schedule did not allow it, combined with the fact that flights from Montreal to New Orleans are hard to get, so I couldn't actually logistically, I couldn't manage it despite the amazing world of logistics and ubiquitous computing. Somehow, no one could figure out a way to get me from Montreal to New Orleans in time for an 8 a.m. panel on Wednesday and still teach a 6 to 9 p.m. class the night before. Interestingly enough, about AI. And today I'm going to talk about AI and the future of our planet. This is going to be a slight diversion. I'm sure I said I was going to talk about smart cities, but I think this is deeply related. In fact, I want us to think about these two sites together because right now, perhaps if you're involved in urbanism, the question of the hinterlands has become quite prominent. And I'm particularly starting to be interested in how we're thinking about AI, machine learning, and ubiquitous computing and big data in locations where we haven't been thinking about them before. And particularly in this particular case, I'm going to be thinking about them in sites of extraction and mining. But these are, of course, closely integrated economies to the economies that produce smart cities, derivative markets, and the other forms of financialization and future betting that I'm actually quite usually right about. So two things might sum up my attitude in this talk, which is the first is Nicholas Negroponte's quote, "Computing isn't about computing anymore, it's about living." And the second one is from an early age, I was very fascinated by uncertainty, by Myron Scholes of the Black-Scholes derivative pricing equation. And I want to think about these two things together, and I also want to think about them not only as a matter of how do we excavate the relations between computing life and speculation, but also to think about how we need to reform our practices and think methodologically about studying large-scale computational infrastructures. So to start, since I'm a real glutton for these large-scale infrastructural sites, and since I've moved to Canada, I feel that and all they do, or no, that's not really true. But one of the big features of Canada is that extraction is central to the economy, and so inevitably one ends up in a site where either oil or minerals are being extracted. And in this case, I ran a summer school to these gold mines in northern Quebec in the area of BTB. And so, aside from smart cities, I'm really interested in smart mining. And in fact, with all the geology preoccupying us in media studies, at least these days, I don't know how it is in science studies, but I know you're also interested in extraction. I wonder why no one seems to actually care about the materiality of finance, the way geology and the biggest algorithmic system on Earth, mainly global capital, are intertwined. So one the minerals most tied to currency and to derivatives is gold, and what you're looking at is a gold mine. This is Malarctic in BTB, northern Quebec, near Val d'Or. And it's a very large site, it's one of the largest open pit sites in Canada, which says a lot because there's a lot of open pit sites in Canada, but it's obviously there's even bigger open pits in the world. But it's the fourth largest in Canada, and it's about 2.5 kilometers wide. Underneath it is another mine that comes from a previous, they bore down, which is about 4 kilometers deep. Because the ore quality is significantly degraded, in fact, there's very little easy mining left on Earth. So you either have to go really deep or you have to go really wide, but you get very little ore quantity for the amount of rock you dig up. And in this particular mine, the amount being mined is only about 1 part per million, which is to say 1 ton of rock, that's a lot of rock, equals 1 gram of gold. While this might seem like an insane thing to do, dig up a whole ton of rock just to get a gram of gold, it's still profitable. It costs $650 a gram to mine gold, according to the geoengineers working at the site, and that's what they told me. And as of I checked this evening, the current price of a gram of gold is $1,286. These are all US dollars as of this morning, so you can't really lose. even if the markets are a little variable. And all the metals are running out. So this is a chart that was shown to me by the geoengineer who works in mine reclamation, um, Professor Mustafa Ben Zazua, who worked with me at this mine. And his argument was that by 2155, pretty much, no matter how common it is, we're going to run out, even from coal, which is charbon. We will dig, we can destroy the earth, we can add all the technology, but basically, his argument is that we will run out, which makes sort of mineral markets and energy markets in things like oil and gas somewhat limited but eternally valuable. So, so this is basically a pretty safe bet because eventually we can't have any more gold, so it'll be valuable in the future in theory. So this is also, however, so you might be asking, why am I discussing this site when we're supposed to be talking about smart things and ubiquitous computing and technology and machine learning and AI? That by the end of the life of the mine, which is right now, this concession lasts 12 years, but might stretch as long as 25, is upwards of 750 million tons of waste rock and tailings, which you're seeing here, images of a tailing pond. So the mine is 2.5 miles, but the entire site is 25 kilometers squared, of which 23 kilometers squared are tailing ponds, which are the result of these chemical processes. This cyanide meets all this gold that needs to be washed out and thrown out. Leaving an incredibly acidic kind of environment behind the mine. This also results in a boom and bust as towns in the region are abandoned or left to die once the labor demand. So northern Quebec is really littered by towns that are empty. So people go through booms. Houses cost $250,000 or $300,000 or even $1 million. People make $150,000 a year, and then within 10 years, this is over. So there's a huge amount of volatility, if you will, in these economies, which also ends up in a kind of resulting poverty and violence. But worry not, this will all be reclaimed, in this case, as a golf course. But usually the industry standard is a boreal forest, since that's originally theoretically what you destroyed. So it can look just like it did before, or maybe better, as this pleasure space, even if a few heavy metals are now in the water. And efforts are made here. This is the final image, then this tour that I went on at this mine, where you can see calcium carbonate being pushed into the water. That's coming off of this mine, that due to its interaction with both the chemicals and just anything beneath the topsoil, which is rock, it becomes incredibly acidic. So it's about 2 to 3 pH coming off the mine, which would kill just about everything. And so it has to be deacidified. And in fact, all those tailing ponds will have to be dealt with and somehow deacidified in order to allow any forest to grow on it. So they're deacidifying this water to a pH of 6 or 7, so in theory it won't kill everything around it. So it's being released back into this lovely forest. After all that sulfur and cyanide went in to get the gold out of the rocks, you have to kind of do something to keep the system functioning as it supposedly did before. And this one I talked to ecologists at the site is called resilience. It's not that things aren't destroyed. Obviously, a 25 kilometer square hole/site is going to destroy something. But it's more that the what we call ecosystem services of the space are being maintained. So what we think are the constitutive elements of the boreal forest are maintained through these techniques. And then one might contemplate, what is this all for? Is it only for jewelry? No, actually, it's not. So over 90%, there's very little gold that actually goes into jewelry. Most of the gold, upwards of 90%, goes right back underground into the vaults of banks in Switzerland and London to act as another commodity grounding the speculation currencies. And in fact, I thought we went off the gold standard, but when I started studying gold, it comes to be that gold is one of the key shall we say, markets in currency market that kind of grounds volatility in other currencies as well as national debts and kind of other forms of debt leveraging. So this is sort of, if you will, still a kind of safe bet to hedge against the other forms of more volatile financial uh, futurities that come in through things like like through different debt and credit debt markets and agreement or kind of deals. So basically, all of this ends up back in these vaults of banks in Switzerland. I just showed you the Bank of London to act as this commodity grounding speculation in currencies, essentially, and betting against other forms of volatility, such as loans to nations and other such large-scale forms of credit market to feed the ongoing need, if you will, to liquefy the planet and hopefully bet on the not so uncertain future. And in the meantime, all this betting can keep going because the mines are supposedly environmentally friendly. So we end up with a kind of smart, resilient green extraction. Now, I tell you this story because it elucidates some of the challenge and possibilities of what it means to think critically and historically, and also just create a kind of infrastructural account of what's happening today with ubiquitous computing, smartness, if you want to call it that, and increasingly machine learning and AI in terms of thinking about how those new infrastructures or those new epistemologies integrate with older forms of infrastructure and materiality. And I'd like to just pose some kind of challenges and possibilities of why this site interests me and what it means for us. First, as a historian of science, it points to histories of knowledge and power. Here I'm showing you Lyell's Principle of Geology coming from 1857. And as a historian, it points to these histories of knowledge and power, the histories of the sciences, geology and ecology, along with theories of evolution and systems that lie within these models. So a lot of my work is about actually the rise of ideas of resilience in the 1970s and the new ideas of kind of flexible and derivative curves and futures that emerge as a kind of relationship between how we're thinking about environment calculatively as well, and how that links up to how we're actually managing environments computationally. So I'm interested in these theories of evolution and systems, and it's also important to recall that behind our theories of technology, and especially of AI, are concepts of evolution and also histories of things such as finance and economics. What constitutes a decision? How do we make value? What kind of algorithms? In this case, derivative pricing is a very vital because gold serves largely as a hedge bet to other commodity market, to other actually monetary markets. So that these kind of collaboration of both high technology and algorithmic finance and these longer histories, right, of geology, colonialism, and data visualization all combine to make this supposedly smart site smart. I also want to argue that this site is interesting to me because it demonstrates a computational and algorithmic technology. So this is the site, again, with my students, is that how computational and algorithmic technologies, such as the Black-Scholes equation and all the smart mining tech that I just talked about, used to get resources out of an increasingly fatigued Earth, reformulate older extractive and settler colonial economies. This mine is, of course, on unceded indigenous lands of the Anishinaabe Nation, but the equations derive from the slave trade. Derivative markets were first used off to set insurance risk by Dutch and then British East India companies. And here I have a series of charts that were compiled. So these are among the first calculative technologies that created new forms of territory. So you can see from these charts that the sea became remapped as a series of risk valuations. And these charts were compiled at Lloyd's of London, which is like a tea house. And what happened at these moments in the 18th century is that people understood that you needed, in order to offset your risk, to merge the risk from, for example, a trip through the Mediterranean, which is a fairly safe and small sea, with a trip to Africa and West Indies, where your chance of losing money is, or losing your cargo, is much, much greater if you're doing a transatlantic voyage versus a Mediterranean voyage. If you combine those two, then obviously you could offset the risks of one voyage with the other. So this was the start of derivative trading in the 18th century, through these insurance markets in largely the slave trade. And as you can see, these are also new forms of territory, in terms of this is how the sea actually, so these calculative technologies created both new forms of territory. You can see from these charts how the sea became remapped as a series of risk valuations and quantified. So it was a quantification, if you will, of the ocean and of territory into kind of a new kind of state space of risk and statistical potentialities. And it also is one of the first technologies that transformed human beings, the slaves, into populations and commodities. So through these risk valuations, human life could now take a sort of monetary or quantified value. And it was only through these technologies that this new type of probability that we could turn human beings into commodities. And that technology, of course, is now continuous throughout, or inheres, if we will, within our contemporary algorithmic financial systems. This also brings me to technologies of time. Because the most heavily derived markets on Earth are in energy. And as we speculate and build tech to hedge bets on literally global survival, we need to attend to the techniques by which we manage and make time in media and technical systems. And of course, how they translate or do not to other systems. So smart infrastructures point to new questions of temporality and scale, both times of geology and times of machines, and algorithmic speculation, of course, of the fragile biological life that lies in between them. In terms of scale, we must think about the term planetary and its relationship to older concepts of globalization. The planetary, for me, differs subtly from the global in that it's not about homogenization through telecommunication networks, intensified international trade, multinational corporations, and the like. In contrast to mid-20th century comprehensions of globalization, the planetary is about disjunctures and differentials, exposures to varying forms of sociological risk. It's about the integration and, in fact, arbitrage through these new algorithmic technologies of differences between places and populations through logistical systems that do not homogenize but rather govern through differentials. As you can see, I have concerns with thinking about difference, time, and also uncertainty and risk as central questions to contemporary media and infrastructural systems, and rethinking the future of politics and ethics in our present through bringing these things to bear. So, this also brings me to the question of materialities, but the materiality of the rocks, but I also want to urge us to start making infrastructure a little less visible, which sounds strange because I'm showing you this beautiful picture of a mine. If people see the fiber optic cable or this mine, we seem to assume that they will care. I don't really think so. I also think that imaginaries, fictions, hopes, and speculations play as much a part of the way we reorganize life, habitat, and territory through new media technology as metals. So I urge paying attention to the material of the earth, but also the algorithm and the forms of knowledge, and in fact the way we're envisioning other futures. This also prompts me to ask about global assemblages and how they afford or incapacitate new forms of action, politics, and territorial imaginaries. So, for example, as a historian, it's really important for me to understand the complex times of finance, the integration of newer logics, such as this equation that emerged in the 70s, older histories of slavery and colonialism, and new technical infrastructures, and ask how such an examination might afford us in terms of complicating action. For example, this is the Kinder Morgan pipeline in Canada. For example, the ways that activists are trying to shut down these oil pipelines through arbitrage between actors and changing the risk valuations on the pipeline to make it harder, if you will, to finance these projects in a new game that pits finance versus finance. On a personal level, I also work with my students. These are my students at this mine to develop science fictions and design. So as a result of this research studio, we developed a website at planetaryfutures.net where we included science fictions, designs, and trying to work with the same mine reclamation engineer to think about how we might imagine what it means to inhabit this space, to both engage the balance of the world and to also think about, though, how we will occupy these supposedly toxic environments. And that is part of a broader research creation studio and research cluster that I run at Concordia, where we're trying to integrate these many, many different forms of knowledge and practice to thinking about different ways to think about the future. So I stand on fiction. Is one of my favorite artists. And I stand on artistic and humanity's place in reminding engineering and technologists that the future is never fully determined. Ultimately, I'm a historian, so narrative and fiction, new forms of science fictions, are really all that I have to offer, but I'm quite proud about that. And for me, the question is how can we speculate more ethically and open the future in futures in plural? And finally, how might speculation become experiment? Also, a smart site. In fact, few industries are more heavily automated and more penetrated by AI and machine learning than the extraction industries and sciences like meteorology and geology. So, in fact, this entire site is automated. They try to keep people out of there, with an exception of the trucks. And in fact, in other mines I've been to in Chile, Toyota is running automated truck driving programs. So the hope is that even those will eventually be automated. And the geological surveys for these sites involve a vast number of sensors, a lot of high frequency radio, infrared, and spectroscopy mapping from the air and satellites, and large amounts of modeling and simulation of both stability and environmental impact, and of course, supply chain optimization. This is a 24/7 operation, and these materials have to be constantly processed and gotten out. And also, because there's such bad ore quality, all the way you get ore out is basically chemistry. So you have to run it through basically a cyanide wash, and the cyanide binds with the gold and gets it out. But essentially, that means that everything you're dumping off it, so you have to regulate that chemical process, and that's usually done paracomputationally. And then, of course, as a result of all this smartness,